Okay, ladies and gentlemen, today we're going to look at reflections and translations. A reflection is a flip of a figure in a line called the line of reflection. Each point of the pre-image and its corresponding point on the image are the same distance from the line. A reflection maps a point to its image. If the point is on the line of reflection, then the image and the pre-image are the same point. If a point does not lie on the line of reflection, the line of reflection is the perpendicular bisector of the segment joining the 2 points. All right, now there's an example of them reflecting quadrilateral ABCD about line M. All right, now I'm going to go down and do some of these down at the bottom down here. All right, I'm going to start with number 1. We're going to reflect triangle JKH about line M. Well, any point that's on that line will stay on that line, so K will also be point K prime, okay? J will need to be reflected, all right? So what I'm going to do is I'm going to line up my protractor so that I am perpendicular to the line of reflection, and I'm going to measure across that line. And it looks like it's about, I'm going to measure in centimeters, about ½ centimeter. So I'm going to go about ½ centimeter across that line, and that will help me locate point J prime. So that point on the other side of that line will be J prime. All right, and now I'm going to draw a perpendicular to line M from point H. All right, so somewhere on that line is point H prime, and I'm going to measure the distance from H to that line. Looks like about 1 centimeter. So if I go about 1 centimeter on the other side, that will be point H prime right about there. Okay, so there's point H prime, and then I can connect H prime to K, or K prime, H prime to J, and J prime, excuse me, and J prime to K prime. And there is the reflection of triangle JKH, or if you like, triangle J prime, K prime, H prime. Okay, all right, now let's go to number 2. We're going to reflect pentagon PLMNO about line T. And notice that point L and point O will not need to be reflected, so all I have to do is reflect the 3 points P, M, and N. I'll start with P. So I'm going to line up point P and perpendicular to the line of reflection and draw from point P across the line of reflection, and then I'll measure the distance from P to that line. Okay, that looks like about 0.6 centimeters. Okay, so I'll go 0.6 centimeters on the other side over there. Let me get lined up here. 0.6 centimeters would be approximately right there. So that is going to be point P prime. Okay, all right, and then I'm going to do M next. All right, so I'm going to line up perpendicular to line T and line up point M. All right, and I'm going to draw a line from point M perpendicular to line T. Then I'll measure that distance. Okay, all right, looks like about 7/10. So if I go 7/10, okay, that would put it approximately right there. So that would be point M prime. Okay, all right, and now I need to reflect point N. So I'm going to line up point N and perpendicular to line T, draw a ray, measure the distance, okay, from point N to that line. Looks like about 0.9, so I'm going to go 0.9. Okay, which would be approximately right there. Okay, and that will be point N prime. And now I'm going to connect N prime to M prime. Okay, I'm going to connect M prime to L or L prime. L to O, all right, and to P, I got to go to P. All right, over to P, and then P to O. All right, and there is that that figure. All right, and by the way, that line's already there. All right, there's that figure reflected about line T. All right, let's go to number 3. We're going to take the the pentagon, Q, and reflect it about P. Well, point T, Q, and U are going to be point Q prime and U prime. All right, so I won't need to reflect them. So I'm going to start with R, and I'm going to line up R perpendicular with R and draw a ray from point R across over there. While I'm at it, I'm going to go ahead and do point S because I'm going to have to reflect it as well. So we'll draw a ray from S across the line P and also from T. So from point T perpendicular to line P. All right. And it looks like R and T are the same distance, so I'm just going to measure that once. Looks like about 6/10 of a centimeter. 6/10 of a centimeter would be approximately there, and 6/10 of a centimeter would be approximately right there. All right, so here's R prime, and this is point T prime. All right, and now I'm going to measure from S to the line of reflection. Looks like 1 centimeter. All right, so go 1 centimeter on the other side, would put point S prime right there. So then I can connect S prime to R prime to Q, right there. Q prime to Q prime and U prime, All right, and then from there over to there, and then back there. And there is that pentagon, reflected about line P. All right, I'll do one more. Let's do the star. All right, there's only one point that does not need to be reflected. That's point A. All right, so A is A prime. And now I'm going to draw a point B. I'm going to reflect point B first. All right, so I'm going to line up perpendicular to line L. All right, and line up B and draw a ray from B. All right, oh, notice that ray from point B went through point E. Now, I'm going to measure the distance from E to that line. Looks like about 1.4 centimeters. About 1.3. And let's see, it looks like maybe that's the same, 1.3. Oh, so this point right here is B or E prime, and point E is E or B prime. All right. And now if I line up points C and D, they're perpendicular to line L, you can see. All right. It doesn't matter. There's the line of reflection. Oh, well, I go through there. So C is also D prime, and D is also C prime. So this figure maps to itself because this point was also on the line. It's not named, but it would stay on that line. All right, so that figure maps over to itself. All right, that's how you can do it not on the coordinate plane, by the way. Okay, all right, now on the coordinate plane. To reflect a point in the x-axis or about the x-axis, multiply its y-coordinate by -1. So in other words, and this is the way I would prefer that you talk about this, xy changes to x, the opposite of y. That's the rule for reflecting about the x-axis, all right? The rule for reflecting about the y-axis is to multiply the x-coordinate, all right? And this is the coordinate rule. xy changes to, multiply this x-coordinate by -1 gives you the opposite of x, y. And now the rule for reflecting a point about the line y equals x is to interchange the x and y coordinates. So the algebraic rule would be xy changes to yx. All right, and that's what you need to memorize when you're doing these reflections. Okay, all right, those are the ones you're going to use on your assignment. So be sure you remember that. All right, let's go look at number 7. All right, number 7 says, and by the way, these are kind of weird, all right, reflecting about something other than the x-axis, the y-axis, and y equals x, but we'll do 7 and 8 as well. Number 7 says to graph a triangle FGH, which is already there, by the way, and its image. So I'm just going to graph the image, okay, in the given line. We're going to reflect about x equals -1. Well, x equals -1 is the vertical line with all x coordinates equal to -1. All right, now if you move perpendicular from F, you have to go 2 units to get to that line, and if you go 1, 2 units on the other side, there would be point F prime. This point G would also be point G prime, and if you notice, H is 1 unit to the left of that line. When you reflect it, it will be 1 unit to the right, and in other words, H prime would. And then you could connect G prime to H prime, okay, G prime to F prime, and then F prime back to H prime, and there is triangle FGH reflected about the line x equals -1. All right, now I'm going to do the other one in a different color. I'll do it in black. It wants us to reflect about the line y equals 1. Well, the line y equals 1 is the line for which all the y coordinates are 1. All right, and if we're going to reflect triangle FGH, then we're going to look at F. F is vertically above that line 1, 2, 3, 4, 5. 1, 2, 3, 4 units. So we'll go 4 units to get to that line, and 1, 2, 3, 4 below, and that would be point F prime right there. All right, point H is 1, 2, 3 units below. When we reflect it, it will go 1, 2, 3 units above, right inside there. That will be point H. And let's call this double prime. This is kind of like the second reflection of this triangle. And then point G is 1, 2, 3 units above. So 1, 2, 3 units below would go to right there. That would be G double prime. And then we can connect H double prime with G double prime, G double prime with F double prime, and then F double prime back to G double prime. And there is the triangle FGH reflected about the line y equals 1. Okay, so we did 7 and 8. Let's go do number 9. X equals 0. That's the y-axis. And the rule for reflecting about the y-axis, all right, is, xy changes to the opposite of x, comma, y. And I would prefer to do this with ordered pairs because I can do it really quick, all right, if I understand the rule. You need to be able to write these rules and all that fun stuff. So A has coordinates of -3, 1. All right, and when we change it, A prime will have coordinates, multiply the x coordinate by -1, A prime would have coordinates of 3, 1. All right, B has coordinates of 1, 2, 3, 3. All right, we're going to transform that to B prime, and that means we'll multiply this x coordinate by -1. That would be -3, and then leave the y coordinate what it is, 3. All right, C, which has coordinates of 2, -1, 2, -1, will transform to C prime, which would have coordinates of -2, -1. All right, and then finally, the fourth point of that quadrilateral, D, has coordinates of -2, -2, and that would transform to D prime, which would be +2, -2. And then you could graph that because it told you to graph it. You always want to follow the instructions. 3, 1, so 1, 2, 3, 3, 1 would be point A. Oops, I did 3, -1, excuse me. 3, 1 would be point A prime because it wasn't reflecting. I was seeing that immediately. Okay. All right, B is -3, 3, so 1, 2, 3, and then 1, 2, 3. There's going to be B prime. Okay. All right, C prime was -2, -1. All right, so -2, that would be C prime, -1. And then +2, -2 will be D prime. All right, so then we could connect A prime to B prime, B prime to C prime, C prime to D prime, and then D prime back to A prime or A prime to D prime, either way you want to do it. But there's what that reflection would look like, okay? All right, I'm going to let you do number 10 on your own. We'll go look at number 11. Number 11, the instructions say, graph each figure and its image under the given reflection. Okay, so we're going to reflect about y equals -x, okay? Well, let's talk about y equals negative x for just a second. All right, that's the line that passes through the y-intercept of 0 and has a slope of negative 1, which would be that line containing each and every one of those points. All right. And now what I would tell you to do is to take a point that you know the coordinates for and just reflect it about that line is what I would do. I would take like 3, 0, okay? And I would say, okay, or maybe let's do 3, 2. Let's take the point 3, 2, all right? And I would have to go, if you're going to reflect, you have to have a slope opposite reciprocal of this slope. This slope's negative 1, the opposite reciprocal of that, because you're going to move perpendicular. The opposite reciprocal of negative 1 is positive 1, so I would go positive 1, down 1 to the right 1, down 1 to the right 1, down a half and to the right a half, and then down a half to the right half, down 1 to the right 1, down 1 to the right 1. That point would reflect to here. And what would happen is that rule for reflecting, and this is a rule that you should know. We don't have this up there, but you should know this rule. Please remember it. XY, if you want to reflect about that, when we changed, we had 3, 2. Well, that point went to negative 2, 3, which was negative y and then negative x. That's the rule for reflecting about the line y equals negative x. So I'm going to just take those coordinates and reflect those points to get the coordinates, all right, of the triangle. All right, well, let me graph the original first. I graphed the original in blue, so negative 2, negative 1, there's point D, all right? And by the way, we'll do negative 1, 3. Let's do that. 1, negative 1, 1, 2, 3. There's point E, all right? And then 3, negative 1. 1, 2, 3, negative 1 would be point F, okay? All right, so D. Oh, I missed that one pretty badly. I'm sorry. Paper got stuck. Got my ruler stuck. Okay. All right, and now we're going to reflect, first of all, this point. Well, that's 1, and then 1 down here, so that point would go down there. I'm going to do it in a different color. That point, let's do the rule first. I think that would be important. If we did the rules, so D, so the rule would be 1 for D, 1, so the opposite of the Y becomes the X, and the D would be 1, 2. So, and that's D prime, I should say. All right, E prime, all right, we would take the opposite of the Y coordinate, that's what that means, so negative 3 for the E prime, the X coordinate, and the opposite of the X coordinate, positive 1. All right, and then for F prime, the opposite of this Y coordinate would be positive 1. The opposite of that X coordinate would be negative 3. And if you notice, that's exactly what I went to when I just said, okay, I'm going to reflect that. That would be 1, negative 3. There's F prime, okay? Negative 3, 1. So negative 1, 2, 3, 1, and there's point E prime. By the way, that's the same thing, 1 unit to get to the line, 1 unit, or one hypotenuse of a unit, or diagonal of a square unit. Okay, all right, and that would be F prime, and then 1, 2, 1, 2 would be point D prime. So you can connect D prime to E prime, E prime to F prime, and then F prime back to D prime. And you should notice that segment DF was a horizontal line. When you reflect it about that line, it's going to become a vertical line. And notice that it is a vertical line. All right, let's go to number 12. In number 12, we are going to transform those about the line y equals x. And if you remember, that's the rule where you just switch the roles of the x and y. So A prime would have coordinates of 4, 1. All right. B prime would have coordinates of 2, 3. All right, C prime would have coordinates of negative 2, 2. Oops, that's 2. Okay. And D prime will have coordinates of negative 3, positive 1. Oops, I didn't switch them. It's supposed to be 1, negative 3. My fault. Let me cross through that. D prime would be 1, negative 3. Not this one. Okay. Now, I'll come back and graph that. Well, let's go ahead and graph that, and then I'll graph the original, because it did say the figure and its image, and you must graph both of them. So I'll go ahead and graph this one, 4, 1. So 4, let's see, 2, 4, 1 is point A prime. All right, 2, 3. So 2, 1, 2, 3 is B prime. Okay, negative 2, 2 is C prime. All right, and 1, negative 3, 1, negative 2, 3 is D prime. So then you could connect A prime to B prime, B prime to C prime, C prime to D prime, and then A prime back to D prime. Okay, all right, so there's the reflection about the line y equals x. All right, and now I'll graph the original at 1, 2, let's see, 1, 2, 3, 4. There's point A. All right, B is at 3, 2. So 1, 2, 3 up 2. Oh, did I? 3, 2. That's supposed to be 2, 3. Ugh, I'm sorry. I graphed 2. Let's see, 2, 3. Yeah, 2, 3. So 2, 3. So B prime's good. Oh, 3, 2. 1, 2, 3, 2. There we go. That point right there is the original B. All right. And it should be in blue. Let's put that in blue. Blue. C is 2, negative 2. 2, negative 2 is point C. And D is negative 3, 1. There's point D. So we would go A to B. All right. B to C. C to D. And then D back to A. All right, and sometimes it helps to graph the line you're reflecting so you can see what it looks like. It should be symmetric about that line right there, and as you see, it is. All those points, C reflects over there, D down, this point down here is D prime. All right, there's how you do that one. Let's turn the page. Reflections. Oh, excuse me, translations. We just did reflections. All right, a translation is a transformation that moves all points of a figure in the same direction. Vectors can be used to describe the distance and direction of the translation. Okay, and you can be given a vector by coordinate vector, by the way, or you could be given a vector with a like this. All right here. This is a directional vector. Okay, all right. And if you're given the directional vector, what you want to do is this. All right. Now, by the way, let's see if we get coordinates here. I want to make sure we get coordinates, which we will get in just a minute. Okay. All right. If we wanted to use this form of a vector, all right, where you have a direction and a distance, the direction is this direction, and the distance is from the tail to the tip, or tip to tail, that distance. So you're going to move all these points in that direction. This amount of distance is what you're going to do. Okay, and I'm just going to go ahead and measure that distance so I can know that that is, and I'm going to measure it is about 1.8. Looks like about 1.8 centimeters. So about 1.8 centimeters in that direction. Now, when I draw a ray from each vertex, I'm going to try to make it parallel to this vector, okay? So if I was going to do that, I could draw one through V if I was, and see if you see I'm trying to be parallel there. All right, out through there, I'm going to do one from U, and I'm going to try to maintain parallel. Okay, so from point U out through there. All right, then from point W, and I'm trying to maintain parallelism with that one and this one. Okay, all right, so I'll go from there out through there, and then from T, maybe, let's see, right through there, the best you can do. All right, and now I'm going to go on each one of those rays from each vertex in that direction. I'm going to measure 1.8 centimeter. Okay, let's start at the top and go 1.8 centimeter would put T prime right there. Okay, and let's come on that second ray from the top and locate W prime at 1.8 centimeters. So that would be point W prime. And then we'll measure 1.8 centimeters in this direction, same direction, and find U prime. And then lastly, we'll locate point V prime by measuring 1.8 centimeters in that direction. So that point right there would be where, okay. So now we can connect W prime to V prime to U prime, okay. u prime to t prime, and then t prime back to w prime. And there we have translated that quadrilateral WVUT to quadrilateral W prime, V prime, U prime, T prime in this direction with that distance, okay? All right, I'll do a couple more of these. Let's do number 14. All right, so I'm going to line up point L, all right, and I'm going to rotate so that my protractor appears to be a parallel. And as you see, that line right there looks like it's parallel to that vector. So point L prime will be out that ray this distance. I'll measure that distance in a minute. Okay, and now I'm going to line up point W, and I'm going to stay parallel to that vector. So somewhere out through there will be J prime. And then I'm going to line up point K and try to maintain my parallelism. Okay, and somewhere out through there. See, all three of those rays that I drew from the three vertices of that triangle appear to be parallel. So now I'm going to measure from tip to tail, or tail to tip, either way you want to do it. Looks like about about 2.8, okay? That's about 2.8 centimeters approximately. So I'm going to approximate about 2.8 centimeters from L. Okay, 2.8 would be approximately right there. Okay, so that point would be L prime. All right, to locate J prime, measure 2.8 centimeters in this direction. 2.8 would be about right there. So there's point J prime. All right, and then I'm going to locate point K prime by measuring 2.8 centimeters in that direction. Okay, so there's point K prime. And then I can connect L prime to J prime, J prime to K prime, and then K prime back to L prime. And notice that these translations should produce congruent figures, by the way. Okay? All right, and it looks almost like a prism once you do that, when you have those rays there. All right, I think you guys can do all those others. Well, let's do one more. I'll do that well, we did a triangle already. Let's do number 16, or 15, excuse me. All right, what I would do with number 15 is, let's just do it. Okay, well, let's start with, what I like to do is start with the closest point to, or the farthest point. Let's go to the farthest point. It doesn't really matter. You can do any of them in any order, really. But I'm going to try to maintain parallel to that vector over there. That's about the best I could do. So somewhere out that ray is going to be A prime. I'll go to B next. Try to maintain parallel to that one that's out there. All right, so somewhere out that ray would be point B prime. Then point D, I'll try to maintain parallel here. Okay, so somewhere out that ray will be point D prime, and then point C prime should be out that ray right there. Okay, now those all should be parallel, and they're not exactly. We're not going to be all upset about it, but do your best you can. Okay, and this looks like about 3 centimeters. So I'm going to go 3 centimeters on each ray. So right there, 1. Okay, 3 centimeters out that one. Just go ahead and mark that off real quick and you get those points. Okay, so from point B, 3 centimeters to locate B prime, and then from point A, 3 centimeters to locate point A prime. All right, so there's A prime, B prime, C prime is down here, and that point right there is D prime. And now I can connect A prime to B prime. All right. B prime to C prime, C prime to D prime, and then A prime to D prime, and I should get the same quadrilateral, which appears to be a little rectangle, rotated in this direction. All right, that distance right there, about 3 centimeters. And that's how you do it, not on a coordinate plane. All right, let's turn the page and go look at the coordinate plane. Okay. All right, a vector can be used to translate a figure on the coordinate plane when written in the form of AB, where A represents the horizontal change and B represents the vertical change. Now, I want to write a coordinate rule for you. So if you see a vector like that and you want to transform a point, let's call that point xy, you can translate that by doing x plus a, comma, y plus b. That's how the coordinate rule for this type of vector, all right? And if you look, that's exactly what they did with this example. It said 2 units to the right, so that would be adding 2 to the x-coordinate, and 1 unit down, that would be subtracting 1 from the y-coordinate. And there's the coordinate rule right there. And that's what you would have to do. All right, now, let's go down and look at number 19. It says to graph each figure and its image along the given vector. I'm going to go ahead and graph the original figure first because that's going to make it easier for me. All right, so -2, -3, and then -8 would be, I think they're counting by twos. Yes, -3, -8 would be point T here. Okay, all right. And U is at -6, +3, which would be approximately right there. Okay, TU. And then point 0, 3, which would be right here, is point V. Okay. All right, and then we'll draw triangle TUV. Oh, I got W as well. I'm sorry. Forgot about that. 3, 0. All right, 3, 0. Good thing I looked. Point W. All right, and we can connect those points in order, and it doesn't matter what order you start as long as you maintain either clockwise or counterclockwise, beginning with any one of them. Okay. All right. So there is quadrilateral TUVW. TUVW. All right, and now I'm going to go ahead and do the rule because I can do the rule and do this much easier than I can move points because I can't see very well. I can see these numbers really easily. I would say, okay, my rule is that XY changes to x plus 4, comma, y plus 5. That's the rule. So I'm going to apply that rule to get to T prime. Well, that means I'm going to take this x-coordinate and add 4 to it. So -3 plus 4, and you can write that down if you want, all right, will give us the x-coordinate. And then -8 plus 5 will, oops, that's a plus 5 will give us the y-coordinate. Or if you just want to just say, okay, -3 plus 1 plus 4 is 1, okay, and then -8 plus 5 would be -3. So there's your coordinates. 1, -3 are your coordinates for point T prime. All right, and I probably would skip writing down the work. It's okay if you do, but if you need to write it down, please feel free to do so. Okay, so U prime, take the x-coordinate, increase it by 4. -6 plus 4 would be -2. Take the y-coordinate and increase it, which is 3, increase that by 5. 3 plus 5 would give you 8. All right, point V prime. Okay, well, did I do the right one? Did I do that plus 4, which is that, and then that plus 5? Yeah, okay. All right, take that x-coordinate, increase it by 4 would be 4. Take that y-coordinate for V and increase it by 5 would go to 8. All right, and then W prime would have coordinates of, take that 3 and increase it by 4 would be 7. Take 0 and increase it by 5 would be 5. And then you can plot the point 1, -3. So 1, -2, 3 would be in the center of that. That would be point T prime, okay, because that's going to move it 1, 2, 3, 4 units right and 2, 4, 5 units up. Okay, so there's point T prime. Okay, right there. Let's see, where are we? U prime. -2, 8. Okay, -2, 8 would be up here. All right, so that would be point U prime. All right, and then 4, 8 would be this point right here. That's V prime. All right, and then 7, which would be right here, 2, 4, 5 would be in the center of that box, W. So then you could connect T prime to U prime, U prime to V prime, V prime to W prime, and then T prime to W prime. And there you have taken that quadrilateral and you have moved it 4 units to the right and 5 units up. Notice that the corresponding segments, UT and U prime T prime are parallel. Corresponding segments UV and U prime V prime are parallel, and so on. Okay, all right, be sure you check to make sure that happens. Let's go and let's do one more. Let's do number 21, all right. The rule XY will change to X plus 3, comma, Y plus -2 or Y minus 2. It's going to give you the same thing either way. All right, so let's take these points, all right, and let's find, let me go ahead and graph the original first, okay? The original is at 1, 2, 4, 6, okay, so there's point A, all right. 4, 5, 2, 4, 5 is point B, all right. C is at 1, -1, which would be in the center of that box right there. All right, point C is, and then -2, 0. Okay, so there's point C, and then over here is point D. All right, and then we could connect A to B, B to C, C to D, and then D back to A. It looks like it might be a rectangle. Okay, of course, mine doesn't look exactly like a rectangle, but you get the picture. All right, so now we're going to find the transposed coordinates, okay, A prime. We will take the x-coordinate of A1 and increase it by 3. 1 plus 3, 4. We'll take the y-coordinate of A and decrease it by 2. 6 minus 2 is 4. So for 4 will have be the coordinates for A prime. B prime, let's find the coordinates of B prime next. Take the x-coordinate 4 and increase it by 3 would make it a 7. Take the y-coordinate 5 and decrease it by 2 would make it a 3. All right, now we'll go to C prime. Take the x-coordinate 1 and increase it by 3 would make it a 4. Take the x-coordinate -1 and decrease it by 2 would make it -3. And then finally we'll find the coordinates for D prime. Take the x-coordinate -2 and add 3 to it would be 1. Take the y-coordinate 0 and decrease it by 2 would be -2. And then you can plot each of those points. 4, 4 would be right here. Okay, so there's point A prime. 7, 3. 7, 3 would be right in the center of that box would be B prime. All right. Oh, where did I put that point? I don't think I put that one right. 4, 4. Oh, yeah. Okay. All right. So 7, what was it again? 7, 3? Oh, yeah, that would be right there. Oops, kind of missed it. Right in there. Okay. All right. That's not right. Hold on a second. Something's not quite right. 4, 2, 4 is good. And B would be 7, 2. 7, 2. Okay, let me make sure B. 7, 3. Yeah, 7, 3 is good for B because you increase 4 by 3 gives you 7. And if you decrease that by 2, 7, 3. Did I plot that right? Yeah, it's right there. Okay, it just doesn't look right. For some reason, okay, up 1/2 and to the right, 1.5. Ooh, okay, wait a minute, 4, 4. Let's check this one. Increase by 3 would be 4. And subtract 2, 4, 4. Yeah, okay, we're good. All right, let's see. 4, -3 would be right here. Okay. All right, and D was, where is D? 1, -2 would be right there. All right, so that point would go here, this one would come here, and that one would come down there. And there you go. You've graphed the parallelogram ABCD and its translated image A prime, B prime, C prime, D prime using the coordinate rule. XY goes to X plus 3, comma, Y minus 2. If you have any questions, please let me know. Either show up in a Google Meet, call me, email me, whatever you need to do. Have a good day. Thank you. Bye.